Okay, we're doing the first in-class conservation of momentum problem. We have an astronaut with an empty oxygen tank at the beginning. So they're sort of floating together. And then at the end, he's throwing the tank away, and by Newton's third, the tank is pushing him backwards. We know the masses, and we know the final velocity there of the tank. So because there are no external forces on the system, conservation of momentum applies. So we'll start with an if chart. So my initial state, my final state. Initially, the astronaut and the tank are doing nothing. And at the end, the tank is moving with a speed of 2 meters per second. I'll just arbitrarily call that direction the positive direction. So if the total momentum before is going to equal the total momentum after, I have to have the astronaut's has to be negative, and the astronaut's mass is quite a bit bigger. So if that's going to happen, if these two areas, these two momenta are going to equal, the astronaut has to be going slower. So to translate this diagram into conservation equation, the sum of momentum initial equals the sum of momentum final. Initially there was nothing. At the end, mass astronaut, velocity of the astronaut, plus mass of the tank, velocity of the tank, and we can solve. The negative here tells us that the astronaut moves in the opposite direction that the tank did, which is good. That's what we saw up there. Alright. So it'll be negative 0.25 meters per second, which is to the left if the tank went to the right.